Hey guys, in this video we are going to look at Chapter 5, Section 2. Here we are going to write a polynomial in factored form. We're going to solve polynomial equations that are in factored form. We're going to find the zeros of a polynomial function by factoring, and we're going to write a polynomial function from its zeros. This first video is just these first four objectives, and then part 2, that video, will cover these last two objectives. Alright, so the first thing we're going to look at is finding zeros of a polynomial function. So in our example, if the directions say something like determine the zeros of the polynomial, so I'm going to write here find zeros. Oh, remember, zeros, that's just, oh, I don't think there's an E in that. That's just another word for roots, answer, solution, right? So we want to solve for x, basically. Well, in these notes here, it says set each factor equal to 0. So this is pretty easy. What we're doing to find the zeros, if it's already in factored form, we're just using the zero product property, right? We're just going to take each of these factors, x plus 2, x minus 1, x minus 3. Again, these factors, these are all the ones in the parentheses here. We're taking each one of these, and we just need to set it equal to 0. And if we solve each equation, like for the first one, I would subtract 2 from each side, so I would get x equals negative 2. From this middle one, I would add 1 to each side, so x equals 1. And for the last one, I would add 3 to each side, so x equals 3. I've solved for x. I found my zeros. So on this answer line, the zeros for this polynomial are negative 2, 1, and 3. And I could go ahead and put that in a solution set, use some braces. Alright, so it's as easy as that. Just use the zero product property if it's in factored form, like it is. That's all we have to do. So go ahead, you try. I want you guys to try this problem below. Don't get fooled by this x in front. Remember, just pretend like that x is in its own parentheses. Alright, so go ahead, you try that problem below. Pause it if you need to, and then continue on with the next slide. Alright, now let's find the zeros of a polynomial by factoring. So in our example below, we have a polynomial. We want, again, to find the zeros. We want to find the zeros, but it's not in factored form. So we're going to go ahead and factor it and then use the zero product property, like we previously just did, to find our zeros. So first, factor, then set each factor equal to 0. This process right here, set each factor equal to 0, that again, that's our zero product property. Alright, so first factor, our first step of factoring always is GCF. So our GCF here is x. If I take out an x, I'm left with x squared minus 7x minus 18. Now, what's left inside, we can still factor. We have this trinomial here, and it's of the form x squared, x, and then a constant. So remember, we're going to say first times last, so 1 times negative 18, and we get negative 18. So factors of negative 18, that sum to be our middle term, negative 7. So we're thinking what multiplies to be negative 18, but adds to be negative 7. And we can go ahead and factor that. We're going to open up our two sets of parentheses. We know the first one is going to be x and x, since it's one of those simple trinomials, a is 1. And to finish it off, we're thinking again what multiplies to be negative 18 but adds to be negative 7. And that would be negative 9 times a positive 2. Negative 9 plus 2, that gives us negative 7. So inside my parentheses, I'm going to write minus 9. And since it's a positive 2, I'll write plus 2. So now I have this in factored form. I'm going to take each of my factors, the x minus 9, and the x plus 2, I'm going to set each of them equal to 0. So x equals 0, x minus 9 equals 0, x plus 2 equals 0. And I'm going to solve so I can find my zeros. Well, this first one is already solved, so it's done. The middle one, I add 9 to each side, so x equals 9. And the last one, I subtract 2 from each side, so x equals negative 2. So the zeros for this polynomial are 0, 9, and negative 2. And there's my solution set. All right, our last goal for this lesson is to write a polynomial function from its zeros. So we want to go backwards. Notice in our example, it says, what is a cubic polynomial function in standard form with these zeros? So it's letting us know what our zeros are. It wants us to go back and write the polynomial. So it wants us to go in reverse now. So it says, first plug, and we're going to say plug zeros into the terms. So what that means, remember right before we found our zeros, we had something like x minus 3 equals 0. We took each of our factors, right, and we set them equal to 0, and so then we said, okay, our 0 is x equals 3. So we're going to go, and now that we know what our zeros are, we're going to go in reverse, and we're going to write each of our factors out. So, oops, I guess I'll just have to scribble that out. So, since our zeros are x equals negative 2, and x equals 2, and x equals 3, the factors are going to be x plus 2. Because remember, to get this to the other side, I'd have to add 2 to get it to the other side. To move this 2 to the other side, I would have to subtract it, so my factor would be x minus 2. And to move this 3 to the other side, I would have to subtract it, so it would be x minus 3. So now here's my polynomial in factored form, but if I want to have it in standard form, then I would go ahead, I have a binomial times a binomial times a binomial. So I'm going to have to use double distribution for these two, and then use whatever I get, I'm going to have to distribute this as well. So then double distribute. All right, so I want to multiply these two specifically together first, because if you notice, they're conjugates of each other. The first term is exactly the same, x and x, but the second term, one's a positive and one's a negative. And if you recall, when you multiply conjugates together, you don't have to FOIL it out. You can skip FOIL and you can go right to Florida, first times first, last times last. Because remember, the O's, the outer terms, and the inner terms would cancel out. X times negative 2 is negative 2x. 2 times x is positive 2x. And when you add them together, they cancel out. So whenever you have conjugates, go ahead and multiply those together first. So first times first, I get x squared. And last times last, I get negative 4. I'm going to keep that in parentheses because I'm still multiplying it with this one, x minus 3. These are not conjugates, so I have to double distribute. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. In this polynomial here, there are no like terms, so there's nothing to combine. And this is my cubic polynomial in standard form. There's my answer. So like I said, we worked backwards. It gave us the zeros, and we went back and we wrote what the polynomial was. All right, so I want you to do the same thing for your last question. Here it is. You try. What is a cubic polynomial function in standard form with zeros 5, negative 5, and 7? And that's it for this video. Make sure you took good notes. Make sure you wrote down everything. And I'll see you guys in class. Thanks.